Hello everyone and welcome back to another SQL interview preparation session on data science with Harivansh. Today we are going to cover two very important SQL interview questions that are asked regularly in data analyst, data engineer and data science interviews. Our first question is, what is the difference between rank and dense rank in SQL? This is one of the most popular SQL window function questions you will encounter in any technical interview. Interviewers love asking this because it tests whether you truly understand how SQL handles tied or duplicate values in a ranking scenario, and trust me, this comes up in real world data analysis all the time. So let's break down both functions clearly, understand the key difference between them, and make sure you can explain it confidently. Both rank and dense rank are SQL window functions. A window function performs a calculation across a set of rows that are related to the current row without collapsing those rows into a single output like group by does. Both of these functions are used to assign a rank to each row based on the values specified in the order by clause. The difference between them only becomes visible when there are duplicate or tied values in the data. Let's look at the example on the slide to understand this visually. Suppose we have a table of student across Suppose we have a table of student scores 100, 90, 90 and 80. Now both students with a score of 90 are tied. So they should logically receive the same rank. Both rank and dense rank agree on this point. They both assign the same rank to tied values. But what happens after the tie is where the two functions behave very differently. With rank, the ranking goes 1, 2, 2, 4. Notice what happened. After the two students who are both ranked second, the next rank assigned is 4, not 3. Rank 3 is completely skipped. This is because rank accounts for the number of rows that shared the same rank. Since two rows occupied rank 2, the next available rank logically becomes 4. This is similar to how sports rankings work. If two athletes tie for second place in a race, there is no third place winner, the next person is fourth. With dense rank, the ranking goes 1, 2, 2, 3. Here after the two students rank second, the next rank is 3 with no gap. Dense rank goes not skip any ranks after a tie. It simply moves to the next consecutive rank regardless of how many rows shared the previous rank. The ranking is always continuous and unbroken. So to summarize the key difference in one line, rank leaves gaps after ties while dense rank does not and always produces a continuous sequence. When should you use which? Use rank when you want to reflect the actual competition style ranking where ties cause a skip, for example, leaderboard rankings or competition results. Use dense rank. When you need a clean, gapless ranking, for example, when you want to find the top 3 salary bands in a company, where multiple employees might earn the same salary at each level and you don't want to skip any band numbers. What is a data type in SQL? Great. Now let's move to our second interview question. What is a data type in SQL? This is a foundational SQL question that is often asked in fresher and entry level interviews to test whether the candidate understands how databases are structured and designed. It might sound like a basic question, but your ability to answer it clearly with proper categories and a real world example demonstrates that you have solid database fundamentals, which is something every interviewer values. A data type in SQL defines what kind of value a particular column in a database table can store. When you create a table in SQL, you don't just give each column a name, you also specify what type of data it will hold. This is important for three key reasons. It ensures accuracy, the right kind of data is stored in the right column; efficiency, the database allocates the appropriate amount of storage for each column; and consistency, everyone inserting data into the table follows the same format and structure. SQL data types are broadly organized into four main categories. Let's go through each one. The first category is numeric data types. These are used to store numbers, both whole numbers and decimal values. Int is used for storing standard whole numbers such as an employee ID or a product quantity. Big int is used when you need to store very large integers that exceed the range of int, for example, a large unique transaction ID in a high volume financial system. Decimal is used for storing precise decimal numbers, for instance, a salary amount or a product price where accuracy to two decimal places is critical. Float is used for storing approximate decimal numbers where high precision is not required, such as scientific measurements or coordinates. The second category is string data types used to store text. Char is a fixed length string. If you defined char 10, it will always occupy exactly 10 characters of storage, regardless of the actual length of the value stored. This makes it ideal for values that always have the same length, like a country code or a gender flag. Varchar is a variable length string. It only uses as much storage as the actual text requires, up to a defined maximum. It is the most commonly used string type for names, email addresses, descriptions, and similar fields. Text is used for storing large blocks of text with no fixed length limit, for example, comments, product descriptions, or article content. The third category is date and time data types. Date stores only the date in the format YYYYMMDD. For example, a date of birth or a joining date. Time stores only the time component, such as the time a transaction was processed. Date time stores both the date and the time together, which is useful for logging events with with full timestamps. Timestamp is similar to date time but is typically used for recording when a row was created or last updated, and it automatically adjusts for time zone differences in some database systems. The fourth category is Boolean data type. Boolean stores only one of two values, either true or false, or equivalently 1 or 0 in some databases. It is used for binary flags such as whether a user is active or inactive, whether a product is in stock, or whether a transaction has been verified. Now let's look at the practical example on the slide. Create table statement for an employees table. Here, here employee ID is defined as int because it is a whole number used as a unique identifier. Name is defined as a varchar 100 because names are text of varying lengths and 100 characters is a reasonable upper limit. Salary is defined as a decimal 10,2, meaning it can store up to 10 digits in total with exactly 2 digits after the decimal point. This ensures the salary is stored precisely without any rounding errors. Joining date is defined as date because we only need to store the calendar date on which the employee joined, not the time. This example perfectly illustrates how choosing the correct data type for each column is a deliberate and thoughtful decision in database design. Using the wrong data type can lead to storage waste, data loss, incorrect calculations, or performance issues. That is why understanding SQL data types thoroughly is an essential skill for any data professional. Thank you.